It's good. Oh, fine. Thanks, Anish. So, okay. So if you take the case for this training is you should be aware of at least it's not about you should know you should have some basics of programming language at the same time on the software development life cycle. Okay. So how it's are developed, okay, and what are the stages in the first development, typical process models waterfall or spiral, or the methodologies like agile. Okay. The other things and all I'll discuss while the training is going on. But a methodology, this big stages of a software development life cycle, everything from the requirement analysis to then design, then again and the QS, finally into the production implementation. So these are basic knowledge is required to proceed further. Okay, so if these things and you should be able to understand the concept of build and release, okay, and at the same time configuration management. So let's do the build management in one simple sentence. This is the by which a product is made ready for distribution to the customer. It's project is started, okay. Actually, this team was involved in the beginning of the project, okay. We'll be really involving in the also in the middle of the project development, okay. We'll be picking up the we'll be coordinating with the development teams. We'll be coordinating with the QA teams at the same time. The cycle will be repeating for a certain time. At the end of the release, we are delivering the complete application, the product to the production teams. Okay, so or something you need to make it deploy into the production environment. So that's the kind of role which you will be playing in the development. Okay, so process. Okay, the complete process delivering from the beginning to the end customer. Okay, the complete process and how you do it, okay, and how do you handle it. So all these things are called build management. Okay. So and again, so two things. Release management is the coordination of all the activities leading to including the product release to the customer. So that goes everything. Managing the the and coordinating with the development, coordinating with the QA and production teams. All these things are together kind of called as a kind of and you will be assigned a team called release management team, and you will be doing all this stuff. Okay. The next, okay. So the something so this is almost if you see it in the market, people have a standard naming standard domain for doing this activity. People call who are relevant, they call it the configuration management engineers, and sometimes management that you guys, and they call as build and release. And together they come from umbrella. Okay. See, if you exact definition of a kind of a configuration management is how to keep track of your product changes from one stage to another stage. The product to a customer, and the customer is looking for some more changes. Okay, then how you are going to incorporate the new changes on the existing product, and how you are going to release the new version of it. Okay, so then the operation management comes into the picture. So when you keep on repeatedly developing the same project, okay, for different enhancements, different features, okay, so you'll a number of features, and how you are keep tracking of it at the same time, very to reproduce the same thing. Okay, at certain time when you're doing these changes, things are wrong, so you will to roll back to the previous state, okay, and give the same product to the customer. So this reproducibility and traceability, that configuration management side. Okay, and to do this, again, somebody to take the ownership and responsibility and perform these activities. Okay, and to perform the complete so in companies they will be dedicated guy will be there to the configuration management, and for management somebody will be there. Okay, in few organizations both are done by a single guy. Okay, so that will be diversified. Ultimately, both are almost together under the same group. And in SDLC, okay, diagram is not that good enough. I just explain you earlier, if we don't consider if there is no build and release management team, okay, into the picture of software development lifecycle, then there will be primarily 5 phases will be there. It depends on the process model, and the number of stages will be increased or reduced, but these are the typical 5 phases of any project development. So before 10-15 years before, we don't have a separate role or separate domain management or build and release management or some business configuration management. Okay, typically they concentrate on the development and the testing and how they deliver to the production. Okay, so this was a process which they followed. But while the things are changing and industry is growing up, okay, and they wanted to deliver the project such a fast, within few weeks. Okay, they want to come up with a new version of it. Okay, so while coming with the new version, what is happening? They are facing many integration issues, okay, and compatibility issues and reliability issues. Okay, see that's the main reason they introduced this team, okay, business management team, so that this non-core activities are isolated and segregated into a different team, and they will take care of it, and their responsibility is to give a smoother product release to the customer, okay, without having any issues at the end of the release. Okay, the main intention of keeping this team in mind, and to do this team is performing many activities. Okay, so all the activities which you are going to learn in the further sessions. Okay, I mean it's something if this team is not there, okay, so what things go wrong actually in the product development life cycle. Okay, it takes too long. Sometimes happens there is a release cycle which is scheduled for 6 months. Okay, in 6 months of time to finish the complete product development and we to release it. Okay, so on 6 months, 3 to 4 months spent for the development and 2 months for test, and remaining 1.5 months for remaining activities designing and deploying to the environments. This happened, right? If you don't consider the this deploy build activities, okay, which are not automated or which are not given much importance, and you may think you can build in a developer machine and deploy it into the servers. Okay, so you can do that as well. The thing is, once the deployment is done, okay, and the further impact, whether an environment or whether the application which you deployed may work or not work. Okay, it depends on how you build it, how you deployed it. Okay, so that's a kind of a release time. If you try to do those if you don't follow any standards, okay, and you try to deploy how you deploy it kind of a development environment, to impact your product, and that will have to fix the issues and all. Okay, so this is one of the if you do the if you don't follow any standards, okay, and if you deploy the thing without versions, without maintaining integrity of the code, okay, so if you deploy it and you cannot expect the output that cannot be predictable again. Okay, it's you not reproduce the same thing in further. Okay, so quality is again the same problem. If you don't follow any standards, this is what you are going to reach, and not useful. Okay, it's something if you are not able to deliver on time, okay, and you are going to spend 1 more month for the delay, okay, then it's going to impact your business revenue. Okay, so plan. Okay, this is something if you don't plan for a release, okay, if your sudden time in the production tomorrow, okay, and there is not planning is there, okay, so that may cause code instability issues. Okay, sometimes some developer may push their code on time, or some does not push it. Okay, so that will again cause code integrity problems, and that will lead to uncontrolled changes. Okay, and that is again a problem of reliability. So issues are there if one follows all the release management standards, okay, release process standards typically, okay, and if you follow, you are going to get you are going to make the complete development process smoother. Okay, and you find all these issues. Distribution installation. See, this is something you deployed everything, okay, and you fixed in last 1 month and the product, and once you release, okay, so there are chances the customer will be facing some problem, okay, and those things you need to fix it. Again, that requires something impacts the support team as well. Okay, they have to spend lot of time to debug the things and all. Okay, and those things you can you could have spent some time in the beginning itself. Okay, prior to is there, you could have fixed it. Okay, so this implicates not following the proper release standards. Follow them. Okay, or build and release management standards, and you have a resource and ask them to perform all these activities. Okay, so properly performing the builds, okay, and setting the releases for each and every version of the code base, okay, and the environments on time, okay, and proper planning of release, if you do all those things, right, so you are going to your will be consistent, and you can try to changes, okay, and you can reproduce them, and you are 100% sure that your code is not breaking, okay, and it releases with having any bugs, and you have time for the release, okay, and at the same time you are maintaining the quality. So if you follow all the standards, you'll be reaching in a proper quality release, okay. Talking about what are the things which we do it as part of this process, okay, and as part of the, let's come to implementation. As part of the implementation, what are the things you do it in the complete role, okay, as build engineer, what you're going to do it, okay. So as an all, I've listed few points here. So feature enhancements, okay, is not defined by you. See, part of the development life cycle, and your development team will take care, okay, fun enhancements of your product, okay. Next, the versioning. Okay, when it comes to the versioning, they will take the help of the SCM team, which is our team. Okay, they will ask what was the previous version of the same application, and based on the number of changes, okay, number of features which you are delivering. Okay, we need to give a certain version to it. Example, okay, recently we have seen 1.8 release. Okay, before that 7, 1.6. Okay, so and there are versions as well, 1.6.1, 1.6.2. So based on the type of enhancements, based on the type of feature which you're releasing, we need the appropriate version to it. Okay, that is the main why, because you're doing the entire release with a version on it. So a version or something like your release name. Okay. Release. Okay, once you decide the name for your release, then you need to plan it. Okay, so in such a way that you have to plan for each and every phase. At the same time, you have to plan for the life cycle. So example, you to complete this in 6 months of time. Okay, in the 6 months, you are going to spend 4 months for development. In this 4 months, don't developers to hard code development for 4 months, and after 4 months, you getting the code at the end of the release. Okay, so that is complete bad practice. Okay, so they need to apply something code in, okay, from day one onwards. So those practices we'll be doing it as part of the our plan. Okay, so that plan contains even the code integration activities, okay, and build activities as well. Okay, so you need to refresh your environment. Okay, so till end of the release, we'll be giving you a small chunks of the product security team for the things. Even QA team won't be having a burden of testing the entire application at the end of the release. So while transforming the code from development team to QA team, we involve there to from the development team, it properly and deploy into the local environments. Okay, so QA environments. Here environment is something like a set of servers where you an application, and make the application running and give it for testing team. Okay, so the process is refreshing an environment that contains these phases: build, package, deploy, test. Okay, this packaging, deploying, testing is an iterative approach until you complete the release. Okay, 4 to 7 steps. You will get some number of times as per plan, and again, this number of times is also described in the plan. Okay, in the beginning, which is shared by your management team. Okay, management team. They'll say you have to iterate these many steps for these many environments, these many times. Okay, you iterate it and doing n number of times. Okay, to do all these activities, you have to depending on some technology tools and all. So those we'll be learning in formations. Okay, so once everything is done, control change. Once you release an application, okay, the previous application, and you check the current application. Okay, your application 1.0 version is already entered production. You are making not one version, the other version. So when you deploy to the production, you have to deploy only the data changes, which is nothing but what are the changes you made from last release to current release. Okay, so control these changes. Assess readiness is nothing but before going to the production environment, giving it to the customers, want to test it in such a kind of a same environment, production environment. Okay, and deploy and ask your Q team and your team and everyone, the stakeholders, take responsibility, test the complete environment, and make sure ready for the release. Okay, that is done on a production day. You need to release your application to the production service. Okay, so the complete life cycle application, how it goes from the beginning, like, when you define a version 2 until it goes to release. Okay, so here participation will be from, this 4, 5, 6, and 7 steps. At the same time, even the 8th step as well, where you need to give the delta changes to your production team. Okay, after in the version from 2nd to 9th. Okay, all this step will be closely involving with the project development team, and you have to help teams perform activity. Okay, so as I think orally about we do all doing the build, package, the test. Okay, if it's a man, it is really difficult for him in the build, what even the package, what even the deploy. Okay, it's all buzzwords. Okay, see this thing I can just say an overview of it with respect to SDLC. I cannot go dig into the what is the build, and I cannot give any kind of a technical definition. Okay, because each buzzword which we discussed here, okay, we are going to thoroughly go through in details of it, and we are going to see the practical examples, okay, and the tools which are, the tools which help to perform these activities. Okay, all these things will sit in the further sessions. Okay, this is where you require to concentration, more importance. This theoretical, anybody if I explain one, we can explain to somebody else. Okay, one web build, I can give in a few sentences source code into the kind of a binary. Okay, it's pretty simple. But when it comes to the practical world, okay, there are really complex parts will be there, and how you're going to handle their builds. Okay, and to do it manually, or are you going to use any tools? Okay, that all depends on your project. Okay, your code base. Okay, depending on your code base, and if it's a very small code base, maybe 5 MB to 10 MB code base with a simple front-end application and backend, you don't need to go for such a kind of a tools and all. You can just do it simple in your IDE itself, which is that will be using a Eclipse, okay, or the IDE to their application. They can use it. The same thing to it in the videos. Actually, you don't. You're be there actually if that's kind of a simple application. Okay, but actually in the real-time world right now, okay, we have very applications, complex applications, have n number of dependencies, n number of modules. Okay, and we have some third-party third-party depends the project depending on some other project. Okay, and which is your client, some other client. Okay, so the applications we have it, and building them manually, okay, getting all the resources is really painful. Okay, so I give a good example while I'm training or management scripting, how difficult it is to build manually. Okay, that is one example. Okay, so if you go ahead with building an application manually, similarly which you do it. Example deployments. Okay, so deploying is nothing but if you have one server and you deploying is simply copying the binaries into the application server. Okay, so the application will be running on it. Okay, so deployments can be done very easily if it is only one server, one application server, 1 DB. Okay, but when it comes to the application architectures, you have some 10 to 20, okay, and you have multiple applications or instances, okay, clustered into different servers, and you need to deploy multiple jar files, war files, and all. Okay, so in these scenarios, it is little difficult for you to do within a half an hour, 20 minutes. Okay, it is very difficult, and to connect to those itself, your complete time will be gone. So your you all those things within a 1 hour or half an hour. Okay, but if you start working on getting the code, okay, and building it and deploying it, okay, so one thing is all these activities manually, your complete time, you might assume you spend 6 hours, okay, in that. It won't even accept 6 hours spending on just build and deploy. You need to refresh environments quite frequently. Okay, see, somebody asked me to do the build every day. Okay, so every day to perform well, if you spend 6 hours, then when you are going to spend for other activities. Okay, so that's a painful point. If you go for a manual thing, so that is then then the market, right? There are a number of tools and scripting languages available. You can use of them to automate your build and deployment process. Okay, so where you help is needed for the development team. Okay, so all the standards you can define, and if you ask the developers to do it, even a developer can also do all these things. Okay, no doubt in it, because he's already doing his own machine for the server side. There's no big deal in it. But the thing is, when it comes to the elements and the server side and kind of a production environment which you want to deploy, okay, so the standard, the builds which is done by developer is not going to help helpful. We need to follow certain standards. At the same time, we need to automate all these processes, okay, manual steps. So manual steps, each and every stage, okay. So from the starting, where you get the code from your controlling system, okay. So here, version controlling system is a place where the developers will be storing their code, okay. So you need to pull code from there, okay. That is also again a manual activity, okay. There also you need to perform some automation, okay. Next, you need to code, okay. Building actually the n number of steps you need to perform, okay. So do it manually is obviously going to take some time. So you have on some sort of a tool or a scripting language, okay. So when it comes to the part, okay, there are really good tools available in the market for Java applications, okay. We have Ant, Maven, Gradle, okay. So all these tools available to automate your job builds, okay. At the same time, if you look at the dot application, I'll just list down those things over here. For okay, the tools are Ant, Maven, which is used by many applications right now, are saying it, and pretty easy compared to Ant and Maven. But these two tools are popular in the market right now, Ant and Maven, okay. When it comes to the .NET application, see, so we use it for Java, may not be for to do the builds in the .NET, okay. So you are depend on some other tools for .NET you have something like an build, okay, and so this language available for .NET applications, okay. That's .NET, that's in VB.NET, any application. So you can make this scripting language to automate your .NET applications also, okay, .NET applications, okay. So C++, okay. So all scripting languages are not helpful for the C++ application. You can depend on make, break. So these are some other C based, okay, completely written in C language. So these are the scripting languages which are available. Use it. You can automate your C++ build process, okay. So it's parts which you handle it, okay. If your development team is working on Java applications, you can depend on these tools. If it is a .NET, you can depend on these tools. Similarly, if it is C++, you can depend on these tools, okay. So go to the build section, okay. So this is the main activity which you will be doing it as part of your role, okay. Deployment, okay. So in the deployment can be done manually as well, okay. So as we all know, if you do it manually, it's going to take some time, okay. So consuming, okay, the is time consuming, and it will be very less, okay, because humans will do the mistakes, okay. So if you are doing the deployment for once, right, first time will be very concentrated, you will be doing it properly. If asking you to do the job 10 times, okay, so it's showing some kind of lenience in the 10th time, okay. So you'll be losing, you won't be getting 100% quality, okay. So you won't get this thing. And one thing is time. Main thing is the time consuming, okay. It's just you are going to spend lot of many time, okay. And the thing is repeating the same task, okay. Repeating, okay. So and deployment in a day, okay. So this is there if you do it manually, but ultimately we are not going to do it manually. We have to take the help of either some tool or scripting languages, okay. So let's talk about scripting first, okay. What scripting is, because there are, let's talk tools first, then I can give a good explanation for scripting, okay. Deployment can be automated with different tools are available in the market. You can automate the deployments. Okay. Example, I can tell you. Okay. And J. Okay. And, so, uh, so there are tools are there like tool is called Octopus. Okay. Different tools are there to make your deployment automation. Okay. So limited. So it's an organization, very medium scale organization. They have application, e-commerce application, and regular releases. Okay, and every week they are releasing some features into the production environment. Okay, they want to test them in locally. Okay, and you are in deployment. So you wanted to use any of these tools. Okay, JBL or UDeploy and all. Okay, so they're pretty expensive to pay for the license. And if your management is not accepting, you are not to uh, tools. Okay, if they are open source, please make use of it. Otherwise, you do it. Okay, it's something like if any open source tool is available, you create it or you make use of, and you automate it using that tool and do it. Okay, so ultimately they are not going to buy any other tool. Okay, so for deployment purpose. So in that, either you look for open source or you have to depend on your own skill set, which is scripting. Okay, if you know scripting, right? So what these tools are doing it. Okay, do it by yourself. Okay, because kind of a programming. Okay, so what tool will do it? Okay, I mean just give a brief explanation what these tools will be doing. It's simple. Here deployment automation is something like you stop servers. Okay, and you you take backup of existing attacks in the servers. You localize it. Okay, and you start the services. So some certain steps. These steps may
Yes.
Yes, yes, I lost the connection suddenly.
Lost the connection some reason. I mean, so we connected. So I can see Amulya, you, Deepti, Nitin, it looks everyone is there. You can go ahead.
Okay, you people can see my screen, right?
Yeah, screen share. Yes.
Okay, fine. So let me continue. Okay. I was talking about scripting and deployment automation tools, right? So if you don't have choice of using these tools, okay, and depend on your scripting skill set, and you can automate all the activities which are done by your tools, okay. But there's more advantages there using scripting, okay. So this is customization, okay, custom automation. You know, your requirement to get the log files from all the servers, okay, and search thing in those log files, okay. This is a deployment actually, like custom automation. Example, I can example. Please load the servers, 100% occupied with the disk space, okay. So kind of requirements you cannot do it with the automation tools, okay. They require a little bit of scripting knowledge. So that advantage, if you know any of the scripting, okay. So any kind of custom automation, okay. So if you know thing, you can automate automation at the same time, you can automate your manual task, other thing about the deployment, okay. So the main advantage of the scripting. So this is something about deployment. There are open source tools also available for deployment automation. Our Stack is one, which is anybody wants, they can give it a try as well. Okay. So done. I want to okay. In the market, people are currently using it, and because of everybody is going to follow one methodology called Agile. Okay. So I will give a explanation about Agile later when I'm talking about Linux and all. So right now, I know what do you mean by continuous integration. Okay. See, continuing suppose uh, started a project, okay, and the month of Feb, okay, and in the month of uh, okay, the and the month of June. So we're going to spend something 4 to 5 months, okay, for development, okay. The clear typical waterfall model, software development life cycle is something project is divided into different modules, okay. Every module they'll be working over here individually, okay. So let me see, okay. Suppose some 10 modules are there, okay. So we have different dev teams, they'll be working on the different modules, okay. And what happens at the end of the complete development phase, what we do is we'll try to integrate all the modules and build, and we give it to the QA team for the testing, okay. That's the conventional model which we followed before Agile come into the picture, okay. So what is happening here, see, people are assuming some when they're developing the modules, right? So all 10 modules are not independent enough, okay. So there are some interdependencies between the modules, okay. What happens, there is interdependencies. The first module guy, instead of taking use of the second module code base, okay, as a dependency, he assumes something and he will make the application code, okay. And the same thing is done by other modules, guys. And at the end of the build, at the end of the development stage, when you're trying to integrate, why? Because the project won't be completing without all the modules together. You cannot give the complete integration to the QA base with the module wise. Okay. So when you're the code base at the end, okay. So people the complete development phase is happening. They are facing n number of issues. Okay. Something we found some 1,000 bugs. Okay. And code base. Okay. Now we found something like 1,000 compilation or runtime errors. Okay. So at the end of the development phase, and immediately give it to the QA team first. Okay, so happening this without with bugs, you cannot give it to the QA team. Okay? And your project developer is saying how much spend to fix this bugs. Okay, so the question of the developer Okay, so we need another 15 days of time. Okay, spend 15 days of time. Obviously, the queuing phase will be moved to 15 days after once they completed all these bug fixes. Now, pushed the complete QA phase to 15 days further. Okay, so spending almost not a planned activity, the complete 15 days stuff. Okay, so this only unplanned thing which came suddenly because of these bugs. Okay, so what happens? So again, the QA team will be having their efforts to put it. Okay, and they say you need to complete in they would say we cannot complete in 1 month. We need whatever the time is scheduled for us. Okay, so because of the okay, they cannot reduce instead. So again, that will be pushed. Same thing with production deployment. So ultimately, what will happen is the process of the product is getting delayed. Okay, so in 15 days, that can be 1 month. Okay, so it's the severity of the number of integrity issues. Okay, so which people, the industry was earlier. Okay, now the a very simple solution for this, which is continuous integration. Okay, so what is continuous integration? This is called as a CI. Okay, so it's continuous integration is nothing but one. Okay, when developers have started coding, day one all 10 modules are not started, only first started. So somebody take a responsibility if module here, module 2 starts in the second day. Okay, so whatever the amount of code is there, if you have any dependency, please to make the build together by making use of the dependent artifacts or dependent libraries. Okay, and when you're doing this, all will be completely green, nothing but without any issues. It won't. You don't think there won't be any issues, but you might be facing issues. But the next issues will be less. Maybe maybe 5 to 20. The count is less. Why? Because the amount of code is in the beginning. Okay, and the number of modules also very less. So what you do is do for every day. Okay, in the sense first day, first modules are developed. Third day, third will added. Fourth day, fourth month. So you keep on adding to your code base, right? So you try to build all together. Okay, and to push these issues to the developers, and you need to put a decision in front of a developer saying every first day of the day they have to fix the continuous integration issues first, then proceed their development. Okay, so this is a policy you need to introduce in your development. Okay, so and you might if the developer doesn't care about the issues and he's keep on proceeding further. So there's another way to you just escalate to the management. Okay, to do and do you right. So who is this guy? Okay, so just a second. Daily building the code, okay, and reporting the issues at the same time taking the responsibility of looking at okay every issues, and that who's doing activity need to get the code from all the developers. So somebody confirm. So I was talking about continuous integration, right? So like, who is going to take the responsibility? We checked with the developers, and if the developer is going to take the responsibility and he cannot work on his items, which development items, so they again given to the engineers. Okay, this team. So you know handle this continuous integration stuff, and how do you handle it? Okay, see, the developer is going to do this job as he won't be time to do the dev items. Okay, then how you are going to get the time to do other stuff? Okay, so then do integration manually is not recommended. So we are going to depend on some tools. Okay, so you have some tools. So if not some tools, you are going to get you will get so much of free time, so that you can automate everything to a tool, and the job which you are doing it right, your tool will do it. Okay, and your job is to configure the tool, okay, and schedule the things and just monitor it. That's your job. Okay, so if you can do this, you can concentrate on your other items, which is the builds parts, deployments, okay, and taking care of version control system, others. Okay, so what are tools available to perform the continuous integration in the market? Okay, so the popular tool is the Jenkins and the TeamCity. Okay, so the bank. Okay, so the number of tools are there. If you really want to know the list of tools, just try to type continuous integration tools in the Google. First page you will get all the tools. So these are the set of tools which for continuous integration. So we've gone through stuff. Okay, the one of the major responsibility and build stuff. Okay, so what to build and what are the tools available, and now section, the other important section was system. Okay. So the typical build and release, or you can call it configuration engineering. Okay, so all this together given to one team, which is a build and release management team. Okay, so version controlling system. So this is also called as the CS. Okay. So example for continuous integration, right? Like what is the need of the continuous integration for the developer? There is a need for version controlling system as well. Okay. I cannot give the in detail explanation about each and every topic need and that what things which you can do it as part of this responsibility. It is difficult in this session. I'll just try to give in a kind of tools which are available to perform this job. Okay. So again, this is another manual. It's an activity. Okay, taken care by the team, and to perform this activity, you can make use of below tools. Okay. So there is one of the tool, and this is also called as SVN. Okay. This is one. Okay. Get Mercury. So in the market, so we make use of any one of these tools to implement version controlling system in the project development. Okay, and this is again us. Okay, SCMT. This is another responsibility. Okay, and apart, okay, we do few other things I'll just mention code review system. Okay, and repositories. Repositories. Okay, so this will be doing it for code review system. We will be discussing Sonar. Okay, and for system we will be discussing. Okay, if from the beginning, for each area there are a number of tools are available. So I'm going to list down what all the tools which are going to discuss. Okay, we're going to learn as part of this training. Okay, so for build section we are going to learn Ant and Maven. Okay, especially Java builds. Okay, we are concentrating only on Java. Okay, deployments, right? So for this, there are scripting. I didn't return any shell scripts for here. Okay, so different scripting languages are there. This is important one. Okay, and your scripting language Perl scripting. Okay, how? Okay, different Ruby is one. So if you're aware of any of the one scripting, that's more than enough. Okay, especially in the market right now, people are looking for the guys who are good at shell scripting or Perl scripting. That will be really good. Why? Because you have to work on a Linux environment. Okay, we call it Unix environment, Linux or Unix environment. Okay, when working on the Linux or Unix environment, you should be aware of shell scripting. Okay, without you cannot automate the small manual activities or small tasks. You cannot write it. Okay, so that's the reason you should have the shell scripting. Okay, if you know any other scripting apart from shell scripting, that is really good and it is an advantage for you. Okay, so in that you should be knowing this operating system. Okay, so that's a mandatory stuff. So the Linux or Unix operating system, learn scripting is really, really difficult. Okay, so the reason as part of this training, we are going to Linux operating system as an OS. Okay, first start with the Linux operating system. I'll walk you through with all the commands, and I'll make you comfortable like how we are comfortable with Windows. Okay, so we comfortable like same thing like how we are comfortable with the Windows. You should be able to do it in the Linux as well. Linux and shell scripting is done. We will be proceeding with how to do the automation with the chef. Okay, so as training, we are going to one scripting language and automation tool. Okay, so I'm going to give explanation about chef. Okay, so because in organizations sometimes they may require the guy who are expertise in the tools as well, DevOps. Okay, these tools also called as DevOps tools, guys. Okay, there is a name called DevOps. Is a new buzzword from last 1 year we are listening in the market. So DevOps is a which is actually used for the deployment automation tools. Okay, so that any of these tools they can you are fit for DevOps tool. Okay, so one two tools. Okay, deployment side, one tool and one scripting and one operating system. Okay, and for continuous integration side, we are going to learn the Jenkins. Okay, and to the version control system side. Okay, so we are learn the server version. Okay, and we are going to learn the Git as well. Okay, these two tools I'm going to train you. Okay, and when it comes to code review system, it is Sonar. When it comes to binary repositories, it is Artifact. Okay, so I covered pretty much all the tools or not. Okay, so this is given in the PPT. Server and Git will be seeing it, and Maven for build tools. For code, I'm talking about Sonar. And for this Artifact tree. Okay, and continuous integration Jenkins. For platform, we are going to go Linux or Windows operating, Linux or Unix operating system, and for that it is Chef. And last one is the application server. Okay, so when it comes to the application servers, nowadays pretty much all the applications are web applications. Okay, so 80 to 90% applications which you see it in the market. Okay, all applications are intra-connected with the net. Okay, so your internet. So typical application require application server to run and host. Okay, so we have different application servers available in the market. You have servers like WebLogic, WebSphere. Okay, Apache Tomcat. Okay, so that servers are there. Okay, and JBoss. Okay. Servers are there, application servers. We can use any of this application server to host a web application and run it. Okay, but again, not depending on us. Your architecture team will be taking a decision where your application will be running, which application, and it's your just responsibility the application into this application server and make it running. Okay, so for that you should be aware of what do you mean by application server, what it does. Okay, how we deploy it, how do we start the application server, how do you do the configuration settings. Okay, so all these things you should be aware of the application server. So that we'll be discussing all the above stuff. All the above responsibilities are done. So this will come at the end. Okay, so as my training, I'm going to discuss about Apache Tomcat. Okay, so I'll give you the complete overview, installation, how to set up, how to deploy everything about Apache Tomcat. At the same time, I'll give you a story of WebLogic as well, not in detail. It's a kind of typical deployments, typical workflow of the WebLogic. Okay, so that will be taken to the WebLogic side. Okay, actually we don't write any test automation suits. We will be having automation teams, okay, so QA automation teams, writing the suits actually, okay. So they will be writing the suits for regression, they'll be writing suits for acceptance testing, they'll be writing suits for smoke testing, okay. So different suits they'll be writing. Suit in the sense like, they're using some tools like, Selenium or Bash or like, APM, some tools are there. They'll be writing that suits, and it's our job to run as part of a deployment, okay. When you perform a deployment into servers, right, how to verify your deployment is proper or not, okay. So unless you open an application through browser and you try to log in and check it whether it is opening it or not, you don't, right. So the same is done by your test automation team using the tools, okay. So it's your responsibility to hook your system, hook the automation system with your continuous integration process, so that you are complete end to end from the beginning, where you get the code to, where you deploy into the environment and run the cases, okay. So this is completely called, good terminology is there called continuous delivery methodology, okay. Continuous delivery. So this delivery is kind of a buzzword which contains all the steps, okay. So first, code, okay, from developer or version controlling system, okay. So you will be getting a binaries, okay. So these you need to deploy it to servers, okay. So once you start this, okay, then once you started, run the test case, run the test suite, then by your testing team, okay, and set, okay, which is supporting, okay. So complete life cycle is there, right, from the beginning to it. The complete process is called continuous delivery, okay. So the industry, the organizations are looking for the candidates who can perform this continuous delivery, okay, as part of their product development, okay. So to perform the complete continuous delivery, you should be aware of each and every stage, what kind of automation you will be doing it, okay. So if at the first get the code, okay, you should aware of version controlling system here, and time of build, okay. So you should aware of the build tools and generating and storing them, okay. So you aware of binary storage repositories and deployments, okay, the scripting or tools, okay, and start service, again it is a part of scripting, okay, and you should know how to integrate with your continuous delivery system, okay, where you are going to get the source from the development teams, and something like a different reporting, binding some, updating some ticketing system, okay, types of reporting systems are there. So all together, if you take everything in a pipeline, okay, that is called the continuous delivery model. So to achieve this, you have to go through all these technical skills, okay, all this knowledge is training. So this is what I want to provide to you, okay. So maybe few things a little difficult for you to understand, the technicals or any tool names and all. It's new for you, but one thing is started, right? So we'll be getting habituated for all these words, and I'll be giving the clear explanation of each and every buzzword, okay. Give the explanation of each and every buzzword of this domain in our session or one of our session. So to the same continuous delivery model, I put in a picture here, okay. So if you take this picture, so here pretty much whatever are discussed and this right. So you can see it with their logos, okay. So first phase you can see it source code. This is also called version controlling system area, okay. So that can be a server, that can be Git, any other tool, okay. So this is a continuous integration system, and the is the continuous delivery system. So all together we call it as this is the ideal continuous delivery process, okay. So this Maven and or build tools, okay. So you get the code, you validate the build, you generate the builds with the build tools, okay. So then you perform some unit testing using JUnit and all, and you do the quality and you do some code quality analysis using Sonar or some other tools were there, okay. So we are going to use the Sonar right now, okay. And after that, you deploy and test the environment, okay, and test the builds. See, this part is continuous integration part. Continuous integration doesn't contain the deployments and post-deployment test cases, okay. But if you hook up that as well, deployments and post-deployment testing, okay, that is called as a continuous delivery process, okay. So the two things people will call you are you aware of continuous integration process, or are you aware of continuous delivery process? There's difference Delivery means everything, end to end. Continuous integration means at code only. Okay? Until you generate the binaries, how good the code is. Okay, how many quality metrics you are following it. So test it at the code level. Okay. So to perform that, you will be using different tools. So for continuous integration, you can use Jenkins, Bamboo, or Travis. These are all the C tools. Okay. So when it comes to the continuous, if you want to make this as a complete extended continuous delivery model, then you have to depend on something like DevOps tools like Puppet, Chef. These are all okay. Or you can hook your scripts as well. If you are not depending on the tools, you can hook your scripts, deployment automation scripts, and you can automate the same what these tools are doing. And this ultimately this area is a servers area. Okay, so this can be cloud servers, this can be cloud servers, this can be servers, anything. Okay, so this is where you will be deploying it. Okay, you can more area self source. Okay, this is testing integration. Diagram should be coming over after here. Okay, once the post deployment is done. So this source you need to run it once the post deployment is done. Okay, that covers pretty much the all and complete bill and release management area at the same continuous delivery model. Okay, this is an introduction session. Okay. Questions?
What are the days that will be in class?
Please come again.
In classes, usually.
Okay, the same time, from PST timing. So here it is 9 to 10:30. We'll be having 1 to 1.5 hour session every day. Okay, so onwards we'll be starting the sessions.
Gonna be from Monday to Friday.
Is that out? Yeah. So we are going to have classes every day. Most probably it is going to be weekdays. We'll let you know if we're taking any classes on weekend as well. Okay.
If we buy classes, they have recordings, right?
Yes. And also we will send you the recording. And the second is what documentation or documents we are showing here, and Chiranjeevi is going to share with you.
Thank you.
Yeah.
Recording, you don't need to do anything. Everyone will get the recording automatically. So it's the email.
Okay.
And the thing is, you just share the documentation with everyone. Whoever is there in the email, just document it. The presentation what we are doing here, just send it to everyone.
I just need the email IDs of all these guys because I don't have anybody's email ID.
You are there in email ID, Chiranjeevi, so that we include you also in the email, right? We must have received the email from Naresh.
Okay.
So just send it to that email. That'll be enough. If someone is missing, we will take care of it. Don't worry about that.
Okay. So send this meeting invitation half an hour or 1 hour before starting, or do I need to send it 1 day prior?
You send it half an hour. Oh no, actually no, because these guys they are in PST time zone, right? So you better send it in the night, okay, so that they will know at what time they're going to have the class tomorrow morning, right? So it's here, so it's nice kind of failure. So they know in advance. Okay.
I mean, will be having 9:30.
Well, just send it in advance, just 1 day before that.
From anyone else?